In the first question, we are asked to graph by making a table of coordinates. If applicable, use a graphing utility. So when you make a table, this is what you do. So here, you know that the domain of an exponential function is all real numbers. So that means you can use any x value. But the key points that we use for an exponential function of the form y equals b to the power of x, right, is -1, 1 over b, 0, 1, and 1b. So here, the b value or the base is 1/3. So when x is -1, 1/3 to the power of -1 is 3. Okay. So 1/3 to the power of -1 is nothing but 1 over 1/3, which is 3. 0, 1, and then 1, 1/3. So if you plot those points, this is what it will look like. So -1, 3 is here. 0, 1 is here. 1, 1/3 is here. So your graph is going to look like this. And then you know that there is a horizontal asymptote at y equals 0. Okay. All right. This question is asking you to begin by graphing 2 to the power of x and then using transformations, graph the other two. So let's do that. So I'm going to graph 2 to the power of x first. 2 to the power of x graph looks like this. The three key points are 0, 1, -1, 1/2, 1, 2. So these are the three key points. Now, if you look h of x, the transformation is that the graph has moved to the left by 1 unit. How do I know that? It's because of this. It's moved to the left by 1 unit. And this tells me that it has moved down by 1 unit, which means all the x values I subtract 1, all the y values also I subtract 1. So the first point will become -2, -1/2, somewhere here. And then this one will become -1, 0. And then this one will become 0, 1. Right? So my new asymptote is here at y equals -1. And my graph is like this. This is the graph of h of x. Then -2 to the power of x. That graph is simply a reflection about the x-axis, meaning all the y values become opposite. Nothing happens to the x value, which means my first point will become -1, -1/2. Second point is 0, -1. Third point is 1, -2. So somewhere here, right? So it's not to scale, but just to show you, the graph is going to go down like that, right? So if I were to graph it properly, the graph would be going like this. Okay. Okay. I'm going to come to all the word problems later because I want to have access to a calculator. All right. The graphs labeled in A to D in the figure represent y equals 3 to the power of x, y equals 5 to the power of x, 1/3 to the power of x, and 1/5 to the power of x. So first of all, I know that C and D are growth functions, okay? Which means they have to be either 3 to the power of x or 5 to the power of x. Now, out of that, which one do you think grows faster? So if you look at some x value, right? So suppose say this is an x value that I'm looking at. The corresponding y value for green is obviously more, correct? So that means this is the graph of 5 to the power of x, and this is the graph of 3 to the power of x. So then you know the two decay functions, 1/3 and 1/5. So you remember that if you have, say, for example, 1/3 to the power of -1, that is 3, 1/5 to the power of -1 is 5. So let's say that I have -1 here, right? So obviously, this has to be 1/5 to the power of x, and this has to be 1/3 to the power of x. Okay, next one. Write each equation in its equivalent exponential form. So I can rewrite 5 equals log 32 to base b as b to the power of 5 is 32. This one can be written as 6 to the power of y is 216. Okay, so the exponent and the logarithm have the same base, and this answer becomes the exponent. Again, we're writing it in the logarithmic form. You can rewrite this as 8 to the power of 1/3 is 2, just so that you can see the exponent form rather as a rational exponent rather than a radical. And then when you rewrite it, this is going to be log of 2 to base 8 is 1/3. Okay. 15 to the power of 2 is equal to x can be written as log x base 15 is equal to 2. Evaluate without using a calculator. Okay. So log 16 to base 4. Now 16 is a base 4 exponent, right? 4 to the power of 2 is 16. So this base and that base gets cancelled. The answer is 2. Likewise, 64 can be written as 2 to the power of what? 2, 4, 8, 16, 32, 64. 2 to the power of 6. So this answer is 6. Log 5 to 1/5. Now 1/5 can be written as 5 to the power of -1. Therefore, this answer is -1. Then log 2 1/8. 1/8 can be written as 8 is 2 to the power of 3. So 1/8 is 2 to the power of -3. So this answer is -3. Then square root of 7 can be written as 7 to the power of half. So this answer is half. Okay, then log base 2 1 over root 2. Root 2 is 2 to the power of half. And because it is in the denominator, it will become 2 to the power of -half. Therefore, the answer is -half. Log 64 8. What is 8? 8 is nothing but 64 to the power of 1/2, right? Square root of 64 is 8. Therefore, the answer is 1/2. Then log 5 base 5 is just 1. Any number to its own base is 1. Then log 4, 1. Log 1 of any base is always 0 because 4 to the power of 0 is 1. Then log base 5, 5 to the power of 7 is 7. And then 8 to the power of log 19 to base 8 is 19. So the 8 and the 8 gets cancelled away, right? Neutralized. Okay. Write the equation of the function graph below. They are both transformations of log x to base 3. All right. So the log function, right, is supposed to look like this, correct? So it has an x-intercept of 1, comma 0. Okay. So, and then So if we are graphing log x to base 3, you know that when x is 3, right, log 3 to base 3 is 1. So 3 comma 1 would have been a point, correct? This is 1. All right. So now based on that, let's look at this second graph first, okay? So you see that this general shape is the same, but 3 comma 1 has now become 3 comma 0. So I think I can write this equation as a vertical shift down by 1 unit. You see that? Okay. Now look at the other one. In the other one, there is definitely an upside down, right? So the graph definitely moved upside down. So if the graph had just moved upside down, what would have happened? You would have had a graph like this, right? So this graph is what you would have had. However, do you see that instead of having 1, 0, you have 1, 1? That means not only did that graph flip, it also moved after that up by 1 unit. Okay. So those are the equations. Okay. So now they want you to graph log x to base 2, and then they are using the transformations and vertical asymptote and all of that stuff. So let's first graph log x base 2. You know, this is the general shape. 1, 0 is a point, and then you're also going to have this is base 2, so 2 comma 1 is a point, okay? And you're also going to have another point here, which would be 1/2 -1. So these are all just inverse of e to the power of, 2 to the power of x. Okay, so now I have to do this transformation for g, which is to move it to the left by 2 units. So that means every x value is reduced by 2, right? So that means this point will become -1, 0. This point will become -1/2, -1, and then this will become 0, 1. And the new asymptote, previously my asymptote was at y equals 0. Sorry, what am I saying? X equals 0. So that was the vertical asymptote. Now my vertical asymptote has moved 2 units to the left. So my new asymptote is here, x equals -2. And my graph is like this. So this is G. In H, the only transformation is you have to move the graph 1 unit up. And when you move a graph up, only the y value changes. So 1, 0 is now going to become 1, 1. 2, 1 will become 2, 2. And 1/2 -1 will become 1/2 0. And because it is just a vertical transformation, the vertical asymptote won't change. Only the horizontal will change that. So this asymptote still remains at x equals 0. And this green one is the graph of h of x. Find the domain. So domain is very important concept in a log function. So let's do the first one. Here the function is log base 5 of x plus 6. The base doesn't matter, the only argument matters. And the only condition is that whatever you input into a log function has to be always greater than 0. It has to be positive. So when you solve for this, x has to be greater than -6. Therefore, the domain of this function is -6 to infinity. That's it. So now do the same thing for the second one. It is log 2 minus x. So again, 2 minus x has to be greater than 0. So which means that -x is greater than -2 or x is less than 2. So this domain is -infinity to 2. Okay, so that is the domain of this function. Finally, I have ln x minus 2 the whole squared. Now, because when you square a number, it's always positive, is it not? So basically, what happens is that everything is going to become positive. So the only thing I need to be concerned about is what's going to make it zero, right? So 2 is the only number that is going to make it zero. So the only thing I cannot have is 2. So what is my domain? Negative infinity to 2, union 2 to infinity. 2 is the only thing I'm not including because 2 will make it 0, and I don't want 0 either, okay? Okay, so evaluate. Okay, log 100. So when no base is written, assume base 10. 100 is 10 squared, so this is 2. Log 10 to the power of 7 is 7. 10 to the power of log 33 is 33 because the exponent and the base have same base and therefore they neutralize each other. ln 1. So remember, log of any base of 1 is always 0. ln e to the power of 6. ln is nothing but log to base e. So the e and the e kind of inverse each other out, and resulting answer is 6. ln e to the power of negative 6. 1 over e to the power of 6 is e to the power of negative 6. Therefore, the answer is negative 6. E to the power of ln 125 is 125. ln e to the power of 9x is 9x. E to the power of ln 5x squared is 5x squared. 10 to the power of log root x is root x. Okay, write the equation in its equivalent exponential form, then solve. Okay, let's do it. Log base 3x minus 1 is equal to 2. I can write it as x minus 1 is 3 to the power of 2. X minus 1 is 9. X is equal to 10. Check. 10 minus 1 is a positive number. Therefore, this is okay. Okay. 2. Log base 5x plus 4 is 2. X plus 4 is 5 to the power of 2. X plus 4 is 25. X is 21. Okay, so the next two questions. Log x to base 4 is negative 3, which means x is 4 to the power of negative 3. And 4 to the power of negative 3 is nothing but 1 over 4 to the power of 3, which is 1 over 64. Okay, log x to base 64 is 2/3, which means x is 64 to the power of 2/3, which is cube root of 64 squared. So what is 64 again? 4 cube, right? So this is going to be cube root of 4 cubed, the whole squared, which is 4 squared, 16. All right. Use properties of logarithms to expand each logarithmic expression as much as possible. Where possible, evaluate without using a calculator. Okay, so when you expand this, right, the first thing I will do here would be to rewrite this as a power. Then, using the power rule, the power can become a coefficient. Then I'm using the product rule to rewrite this as a product of two logs because 100x is 100 times x. And what is log 100 is 2. So then I have 1/2 2 plus log x, which is nothing but 1 plus 1 half log x. Okay, that is the answer to this question. The other one can be written as log x over y to the power of 1/5, which is 1/5 log x over y, which is nothing but 1/5 log x minus 1/5 log y. Okay. Okay. So now I'm going to expand it and I'm going to try to do it in one step. So I want you to just follow with me and see if it makes sense to you. Okay, I'm going to do the first problem here. So remember, what is the rule? A power becomes a coefficient, products will become sum, quotients will become difference, and anything in the denominator will be preceded by a negative sign. So using all of those, I'm going to write it like this. Okay, do you see how simple it was? So the x cubed, so ln of x cubed will become 3 ln x. Ln of x squared plus 1 to the power of 1 half will become 1 half x squared plus 1. And the minus in front of the 4 ln x plus 1 is because x plus 1 to the power of 4 was in the denominator. Now I'm going to do the same thing for the second problem. I will have log 10 plus 2 log x plus 1/3 log 1 minus x minus log 7 minus 2 log x plus 1. Okay, just going to leave it like this. You can simplify log 10 as 1, but I'm just going to just leave it like that. Okay. Okay. Use properties of logs to condense. Now we are going to write it as a single logarithm. Okay, so let's do 1. So the base is the same. That means I can combine that into 1 log and the difference will become a quotient. I simplify this. When I divide, I get 32. So this makes it 5. 2 to the power of 5 is 32. Then the second one can be written as log 2x plus 5 all over x. Just leave it like that. Okay. And then the third one can be written as log x y cubed. So the sum will become a product. Okay. The 3 will become the power of y. Again, we are condensing. Okay. So the first one is going to become this. So I'm going to do elaborately for the first one, and then we will do it quite easy, like quickly for the second one. Okay. So let's do the first one a little bit elaborately. So I keep the 1/3 outside. Don't do anything with it. So 5 ln x plus 6 can be written as ln of x plus 6 to the power of 5. Okay. So this is what I have in the first step. In the second step, what I do, all the negatives will go in the denominator, right? So this will become under 1 ln. This will become x plus 6 to the power of 5 over x times x squared minus 25. Okay, so the x and the x squared minus 25 both go in the denominator. Then the 1/3 is applied, has to apply to the whole thing, correct? The coefficient. So this will become ln of x plus 6 to the power of 5 over x times x squared minus 25, the whole thing to the power of 1/3. Okay. next one, I'm going to write it in one step. Okay, so there is one giant log because I'm condensing. This and this are in the numerator because they have positive coefficients. So that means x times x squared minus 1 is in the numerator. The 7 and x plus 1 is in the denominator, but it has to be multiplication, right? So that when you expand, it becomes log 7, negative log 7, negative log of x plus 1. Okay. So log 6 base b can be written as log b. 6 is 2 times 3, right? So this is log 2 plus log 3. Now, what is log 2 according to them? It is a, and this is c. So this is a plus c. Now, log 2 over 27. So this one is log b, base b, 2 over 27 to the power of 1/2, correct? So this can be expanded as 1/2 log base b of 2 minus 1/2 log base b of 27. And this is 1/2 a minus 20. Okay, I'll write one more step then. So this can be written, I'll just leave it like this for now, but rewrite this 27 as 3 cubed. So the 3 will come as, I'm sorry that I'm taking it over here. So this is 1/2 log 2 minus 3/2 log 3, right? Because the power becomes the coefficient, okay? So the final answer for this would be 1/2 a minus 3/2 c, okay? Determine whether each statement is true or false. Where possible, show work to support your conclusion. If the statement is false, make the necessary changes to produce a true statement. ln E is 0. Okay. So think about it. ln E. What is ln E? ln is nothing but log to base E. So you know that what number? So e to the power of what gives you e? E to the power of 1 gives you e. So the answer to this has to be 1, not 0. So this is false. Okay. Second one, let us try to expand this and see what happens. So when I expand using the product rule, I will get this, right? And so I expand it further, I will get this. Okay, this is my left hand side. My right hand side, when I condense, it becomes log base 4 2x the whole cubed. 2x the whole cubed is not 2x cubed, right? So again, this is false. Then let's do 3 now. Three. So let me take the left hand side. X log 10. So this x can become a power, correct? And what do you do? The power rule? The power rule says that, or in other words, you can do one more thing. You can do it like this, or maybe there is an easier way to show this. So look at this. You know that log 10, right, to the power of x, this is equal to x. So this becomes x times x, which is x squared, right? So this statement is true. All right. Now, what about this statement? What is ln1? ln1 is always 0, correct? So this is also a true statement. Okay, let's solve some equations. Okay, first one, 3 to the power of x is 81. I rewrite 81 as 3 to the power of what? 3 to the power of 3, 9, 27, 81. So 3 to the power of 4. So which means x is equal to 4. 5 to the power of x is 625. What is 625? 5, 25, 125, 625. So 5 to the power of 4. So x is equal to 4. 3. 3 to the power of 2x plus 1 is 27. I can write 27 as 3 cubed. So 2x plus 1 is 3. 2x is 2, which means x is 1. Okay. Okay, 4. 5 to the power of 3x minus 1 is 125. 125 is 5 cubed. 3x minus 1 is 3. 3x is 4. X is 4 third. 5. 4 to the power of x is 32. 4 to the power of x is 32. Okay, I cannot rewrite. I can do this if I want. I can rewrite them both as base 2, right? So I can write 4 as 2 squared. So this becomes 2 to the power of 2x is 2 to the power of 5. So 2x is 5, x is 5 halves. Okay. 6. 125 to the power of x is 625. What is 125? 5 cubed. 625 is 5 to the 4th power. So I have 5 to the power of 3x is 5 to the power of 4. 3x is 4. X is 4 third. 5 to the power of 2 minus x is 1 over 125. 125 is 5 cubed. So this is 5 to the negative thirds. So 2 minus x is negative 3. Negative x is negative 5, which means x is 5. Okay, first one. 3e to the power of 5x is 1977. Divide by 3 on both sides. What does that get me? 6, 17, so that is 5, 659. Am I right? Okay. So 5x is ln 659. X is ln 659 over 5. 2. E to the power of 1 minus 5x is 793. 1 minus 5x is ln 793. Negative 5x is ln 793 minus 1, which means x is ln 793 minus 1 all over negative 5, which can also be written as 1 minus ln 793 over 5. Okay, next one. E to the power of 5x minus 3 minus 2 is 10, 4, 76. E to the power of 5x minus 3 is 10, 4, 78. 5x minus 3 is ln 10, 4, 78. So 5x is ln 10, 4, 78. Oh, what did I say? 79. Oh, it's correct. Okay, plus 3. X is ln 10, 478 plus 3 all over 5. This one I will convert into the log form. X plus 2 is log 410 base 7. X is log 410 base 7 minus 2. Okay. Solve. So in the first equation, I don't have like bases, correct? So I am going to take ln on both sides. So when I take ln on both sides, what happens? The power can become the coefficient. Don't forget to put in parentheses, so can distribute. So you have 2 ln 7. So 2x ln 7 plus ln 7 plus x ln 3 plus 2 ln 3, right? Equals, I meant. So collect all the terms with x to the left hand side. Move this to the right hand side. Factor the x out. And then divide out. So your answer will be x is 2 ln 3 minus ln 7 over 2 ln 7 minus ln 3, and you can leave it like that. Okay, then the second problem. So if you look at the second problem, you immediately see that it is quadratic, right? So I'm going to do a quick u substitution here, and I'm going to say let e to the power of x be some variable u. Then e to the power of 2x is nothing but e to the power of x the whole squared, which is u squared. So my equation can be written as u squared minus 2u minus 3 is 0. So I can factor it like so and then solve it. Then I substitute back. So I have e to the power of x is 3, e to the power of x is negative 1, x is ln 3, and e to the power of x can never be a negative number. So there is no solution here. So this is the only answer. Okay. Let's solve the first equation here. So here you have difference of two logs. So I'm going to write it as one log of a quotient. And then I'm going to convert it into the exponential form. 4 to the power of 1 is 4. Then I will cross multiply like so. Okay, I'm sorry that I need to take it like this. So then I expand the right side. I move things around and I get x equals 2. I should always check my answer for a log equation. So how do I check? In your original question, there are two arguments, right? There is an x plus 2, there is an x minus 1. So 2 plus 2 is a positive number, 2 minus 1 is also a positive number. So this solution is acceptable. Okay, now I'm going to do the second problem here. Again, first thing I want to do is I want to collect all the logs to one side and just leave the number alone. You see that I could use the quotient rule, but I don't see any reason to here because actually what is log 9 to base 3 is 2, isn't it? So it is actually, there is no variable there. So I can rewrite it like so. So I add 2 to both sides and I get this. divide by 2, I get this. Then I convert it into the exponential form. 3 squared is 9. I subtract, I get x equals 5. Check. The only term with the variable, the argument x plus 4. 5 plus 4 is a positive number, so I'm good. Let's do 3 here. Again, here I will bring the other log to the left-hand side. Oh, wait a minute. That's also a number, so I don't have to bother. So let me just keep it like that. And I'll keep the log on the left-hand side. And I will write log 4 base 2 is 2. Okay. So 5 minus 2 is 3. Then I divide both sides by 3. And then I convert it into the exponential form and then add 1 to both sides. And check 3 minus 1 is a positive number, so we are good. And then the last problem. Okay, so here I have 3 of them, and I'm going to combine it into a single log, right? So the x plus 6, I'm sorry, x minus 6. The x minus 6 and the x minus 4 are in the numerator, x is in the denominator, okay? This is what I have. Then I convert it into the exponential form. So 2 to the power of 2 is 4. Then I will distribute my numerator, okay? So then I get x squared minus 10x plus 24 is 4x because I cross multiplied the 4 and the x. Then I bring the 4x to this side and I rewrite it as a quadratic equation. Now I see whether I can factor it. I can. I can write it as x minus 12 and x minus 2, which gives me two solutions. X is 12 and x is 2. Check. If I take the 12 and put it in here, positive number, good. Now if I take the same, if I take the 2 and put it here, this is a negative number. This is also a negative number. So this doesn't work out. So I have only one solution, and that is x equals 12.